The reference angle is an angle from the x-axis to the terminal side. However, it could be from the positive or negative x-axis. So in this case, we have an angle here. The reference angle is always acute, meaning less than 90 degrees. So this theta wouldn't be our reference angle. And it's always positive, even if it's going the wrong direction. This reference angle we're looking at here, I'll call it alpha. It is going clockwise from the x-axis to the terminal line. However, we're still going to call it a positive number. In this case, theta is 135 degrees. So our reference angle is going to be 180 degrees minus 135, which gives us this angle right here. 180 minus 135 is going to give me 45 degrees. Let's look at some other angles and see if we can find their reference angles. What if we have a theta of negative 60 degrees? Something like this. That's theta. What would our reference angle be? Well, the angle between the positive x-axis and theta, that's still 60 degrees. However, since we're going to make this be an acute angle, we're going to call it positive 60. The actual angle is negative 60, but the reference angle is positive 60. And that tells us when we go to look at our trig functions, the values of the trig functions will be the same for positive or negative 60, with the exception that sine and tangent will both be negative in the fourth quadrant. So now let's consider the angle theta equals 210 degrees. What would our reference angle be? Well, 210 degrees is in the third quadrant. It would be somewhere around here. And when we do our standard position, we end up with this angle here, theta. Alpha will be the reference angle between the negative x-axis and 210 degrees. And since we know this is 180, instead of taking 180 minus 210, we'll take the larger number, 210 minus 180, and that gives us a reference angle of 30 degrees. Now, had we taken 180 and subtracted 210, we would have gotten negative 30 degrees. We just need to remember that reference angles are always positive, so if you just discard that negative, you'll be fine. Let's consider 17 pi over 6 radians. Now, something that always helps me when I look at pi over 6 or pi over 4s or pi's over 3 is to remember that 2 pi in this case will be 12 pi over 6, because 12/6 is the same as 2. So we know this is going to be more than one full circle. So we go around, there's 2 pi, and that's 12 pi over 6. And we know that, let's see, that's another pi over 6, so that's 13, 14, 15 pi over 6 is here, the positive y-axis. And then 2 more, 16 and 17, gives us an angle somewhere in the second quadrant in this area. So this is our theta of 17 pi over 6. Our reference angle is going to be the angle from the negative x-axis up to this terminal side, and we need to figure that out. Well, 17 pi over 6, it's coterminal with 5 pi over 6. We know that 180 is pi, or, again, thinking of it in terms of over 6s, it's 6 pi over 6, because 6 over 6 is 1. So now it makes it easier for us to subtract 6 pi over 6 minus 5 pi over 6 gives us the reference angle of pi over 6. Again, watch your fractions, practice with them, and enjoy them.